Hello everybody, welcome to my channel. Today we have a very good problem for you guys called nested list weight sum. So let's quickly read the prompt statement, right? So it says we're given a nested list, right, of integers called nested list, right? Each element is either integer or a list whose element may also be integers or other list, right? So the depth of an integer is the number of lists that it is inside of, right? So for example, the nested list, this one, right, as each integer's value set to its depth, okay? Return the sum of each integer in nested list multiplied by its depth, okay? Pretty simple prompt statement, right? So let's quickly see what they're talking about, right? So we have this simple nested list, and we have 1 and 1, right? So those are the depth of 2, right? The 2, because it is, not inside a, it doesn't have, like, it's not inside a bracket, right? So it's at the first layer, right? Which is the depth of 2, right? And also this one is at the depth of 2 because it is inside of another bracket, right? Apart from the original one that we have here, okay? So that's why we get 2, right? So if there was an n one, right, we would keep going into, because it would be another layer, right? An extra depth, right? Which would increment, right? So our job, right? Once we identify the depth that a particular integer resides in, right? We most simply multiply by the depth that it is in, right? Its value, right? And then we add it to the running sum that we're keeping track of, right? So, for example, right, we would encounter, so this is first list, we would go in there and then trying to calculate it. So we see the integer, they will multiply by depth of 2 because every time we go to another layer, we also will be incrementing the depth, right? So we can multiply the values of the integers accordingly with that depth verb, right? Multiply, we get the value, get 2 here, we get 2 here, right, which is 4 from this particular layer, right, list. Then we go back, then we see this 2 is at the first layer, so we multiply 2 by 1 only, right, because that's what it is, that's the depth of it, right? It's not inside of 1, right? And then we got that, we got also 4, we got 6, and then we do 2 plus 2 again, which is 10, and we return 10 as the total one. So it's as simple as that, guys. Let's go through this example, right? We have this first node, this first number, right? It's not inside a bracket, right? It's only inside the first original bracket, right? So it's at the first layer, right? So it's not nested. So this is the first. We get 1, right? We have 1 to our total. Right? 1 times 1 is 1. Then we go inside of it. We see this is another list, right? So we're gonna go ahead and explore that, right? Then we see this thing. We do 2. Because that's 2 because it's inside of an one, right? 2 times 4 is 8, right? So 8 plus 1, 9. Then we explore, we go to the next number. We see that it is not a number, it is a list, right? So we go ahead and explore, right? Because this number is inside of another list, right? So we go ahead and explore. So now we also, this is another layer, right? Because it's another bracket that's part of, right? So we see we got 1, 2, 3. So it's 3 layers in, right? Image, okay? So we do 6 times 3, right, which is 18. Okay, we get our number 27 here, guys, right? So it's as simple as that, guys. All right. So that's kind of the walkthrough. Is 0, then 0 times 1 is 0, right? That's kind of what we have here. So how do we go ahead, right? So there's a couple ways of doing it, right? But we see that we need to explore, right, things in every time we encounter, say, another layer, right? Potentially we need to explore that, right? And I think DFS naturally, intuitively fits this problem because we go ahead and explore every time we encounter another bracket, right? We just go ahead and explore, get the answer, right? Get the sum of that, right? And then return it to our parent, and then we add it to the total sum, guys, right? All right, so that's kind of how I would think about it, right? So we start off, by, just going, so each item of the list, right? We would simply just see the first item, right? See the first item, then we just see it's the list, then we go ahead and explore, right? Recursively, we're gonna do that, right? Recursively explore. So now, cool, I'm gonna wait for this answer, right? And then and then now we get this list, problem that we're solving, right? And then we see also we're gonna increment the depth, right? We can also pass in depth plus 1 every time, right? Which makes it pretty simple to do, right? So we do depth. So at the first layer we see that it's a list, so we do depth plus 1. And then we do 1 times 2 is 2 plus 2 times 1 is 2, so that's 4. So 4 return back to the first layer, and then we go ahead and to the next item, right? So right now the total sum is 4, and then we go ahead and see it's a number, so we simply just multiply 2 times 1 because at the first layer, right? Okay, and then we go here as well, we see it's a list, then we go ahead and explore on it, right? And then we do 1 plus 1 to the depth of the current, right? Plus 1, and then we do the same thing. It calculates its sum, right? Weighted sum, right? And then return that back to us, right? And then we just simply add it to the total, right? And then we return that number to the thing, right? So the same thing will apply here, right? We see 1, we add it 1 times 1, then we see another bracket, so we do def plus 1, 1 plus 1 equals 2, right? And then this layer, right? We see it's a number, so we go ahead and straight up and do it, and then we see 6, we see it's another bracket, right? So it's an AND bracket, so a nested one, so we do def plus 1, so that it's, pretty easy to do that, right? So you see that, the more in we go, right, the more nested the numbers are, right, the more weight that they have, right? So it's kind of how we're going to do it, guys, right? So hopefully it makes sense. I think the walkthrough of the code will make even more sense, guys, right? So let's quickly go ahead and do that, right? So what we're going to do, we're going to use a helper function, right? I told you guys we're going to use a depth first search approach because it's going to help us in easily solving this intuitively, right? So we start off with the first nested list, right? Okay. And then we're going to use helper function. So it's going to take in the same thing as here, right? Nested list. Let's call it list. And then we're going to pass in a depth variable, right? It's going to help us keep track of the different depth that we're on, right? So we're going to have a for loop, right, to iterate through the list that we have, right? So what we're going to do is going to be nested integer, right? Because we have a list of nested integers. And list, right? So we're going to need to keep track of the sum, right? H level, right? So we initialize it to 0 initially. All right. So now we're going to do there's 2 cases that we can have, right? Also, we're given this this interface that we can look at, right? To see what functions we have available, right? So how do we know when we have an integer, and how do we know if we have a listener, right? We have different APIs here that we could use, guys, right? So we just see so we could ask if it's an integer. We could ask if it's a list as well, right? We could get the list. We could add integers to it. We're not going to need that, right? So I think what we need is to decide if it's an integer or not, right? I think that's going to be useful to us, right? So if it's an integer, right, it's handled a case where it's pretty simple. So n is an integer. Okay. Then we simply, what we're going to do, right, just add it to the total sum that we have, right, which is n dot get integer. Right? I think that's why it is. Right. Get integer, yeah, I'm right. Okay, returns the integer, right? Also, right, we could just do get the integer, right? We also need to make sure that we take into account the depth of it, right? Because the more nested it is in, right, the more that it's going to the more weight that it's going to have, right? So the depth matters here, all right? The depth matters here. So after that, right, so we have this other case where it is not a integer, right? So it must be a one of those lists, right? So what we're going to do is to just get list, right? And then we pass in the depth, right? Also, that we know that we need to do a plus 1. If it's a list, so it's a nested one, right? So the depth increases further, right? So it's kind of what just like at the end of walkthrough, right? So we increase the depth as well, right? And then we have the sum. Yeah, I think it looks good so far. And after that, all we got to do, return sum, right, to our caller, okay? All right, it's just like we did here, right? We see that it's so we're passing this whole list, right, to the thing, right? So there's the whole list, which is the big list that we have here, right? The first item that we see, it's not an integer, obviously, right? It's a list, right? So we pass in the list, right? Sub problems, and then we increment the depth, right, to be 1 plus 1, right? So what we do here, all right, and then so now we need to solve this one, this first, right? It checks for each item in the list, right? So she's 1, it's integer, so we multiply 1 times 2, and we get 1 times 2 again, right? Then we return 4 to the the first column, right? Which is the original big list, right? And then we keep doing that, right? So that's kind of how it works, guys, right? So let's run the code to see if we pass these small test cases. Awesome, looks good so far. Spread submit. Awesome, guys, we would pass all the test cases, guys. If you guys found value, you guys understood the thought process, let me know that in the comment section. If you're new here, make sure to subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.